Hello, everyone, and welcome to today's public webinar entitled Building Skills in Virtual Training Through Interactive Activities. You are here with two folks from TPC Training. My name is Ryan Smith. I'm a product manager of our instructor-led training here at TPC Training. And I'm also joined by one of our great instructors, Greg Sutton, from TPC Training as well. And he's going to walk us through some really great examples of interactive activities that are accomplishable and definitely feasible to do in a virtual environment. So before we get into the meat and potatoes of this presentation, I would really like to let everyone know here that this webinar is being recorded today. And so if, for any reason had to miss this webinar or one of your colleagues had to miss this webinar, we will be posting this recording up on our website within about 2 business days of the date of this webinar. I also want to let everyone know that the PDF of these slides will be emailed to you within those 2 business days of the webinar as well. You'll be getting an email from me personally. And then finally, I want to let everyone know that this is not a pre-canned recording. This is actually live right now in this moment, to the point where you can actually interact with me and Greg as part of this panel by going up to your toolbar at the top of this window, and you'll find the Q&A button. And in that Q&A button, you can feel free to type in any questions you might have for us. And we really look forward to seeing and answering your questions at the end of this session. So feel free to use that Q&A function throughout this session. And finally, this webinar is not a one-time deal. This is actually part of a series of all about virtual training with our company. So if you missed kind of digging into the idea of skills itself, what are skills and how to verify those skills, that's another webinar all about skills verification. And then we also have another webinar that we've done about 2 weeks prior to this one, and that was all about the best practices on the hardware and software side and some of the best practices of techniques that instructors can employ to engage their students in virtual formats. So stay tuned for that one as well. And definitely feel free to watch that back at the link I send you after this webinar is complete. So I'll give you a quick rundown of what we're going to get into today. First, I'm going to really run us through, this is a big question we had last time, so I wanted to run us through this time of the real comparison between classroom and virtual environments when it really comes to these skills, right, and building skills. Technical interactive activity demonstrations are going to be next. We're really going to hand it over to Greg, and we're going to just really go through a bunch of different examples in rapid succession to show you all the different types of stuff we can do in the classroom and that we are doing in the classroom at TPC here. I also want to let everyone know that we can't get into too many details on these as much as both him and I want to on some of these demonstrations. We're going to be just getting the really skimmed surface of showing you kind of what the nuts and bolts look like on these things and examples of types of interactions we can have. And then we're going to move on to the next one to give you really, hopefully, as much inspiration about some of these interactive activities that maybe you can do for yourself or that you can expect from virtual training in the future. And then we're going to open the Q&A line from there. So let's start with this comparison. I'll run us through that comparison and then I'll hand it over to Greg. So our real, I think, challenge right now in the training industry is how can we compare the classroom to the virtual format, right? Well, the classroom has what you would expect, tables and chairs, right? You're sitting in hopefully a quiet, controlled space in a room, watching an instructor communicate. Whereas in the virtual format, you're using a computer and video chat, obviously. But that really just leads to a whole different type of experience where you're looking at a screen and you're interfacing with keyboards and mouses and a screen instead of, a table and a chair and maybe a pen or a pencil, which obviously you can have a pen and a pencil in both formats. In a classroom, really a projector is the main method of presenting material to large groups of people to see. Whereas in the virtual format, we have the screen share that's used. And that is really something that you can do over any video chat software now, show your screen, and that comes through in crystal clarity to anyone watching that can see it more up close than maybe in a projector. Face-to-face interaction, right? This is something that comes time and time again when people say, you know what, I really want to go to a class for that face-to-face interaction. But as you can see here, hey, we're here now, face-to-face right in front of you. It is through a screen, and that is something that takes some getting used to. But it's definitely possible in virtual learning with the help of a good webcam and a good microphone. Whiteboarding, right? when you're going through ideas and talking about what you're learning and what happens at your job place with safety or with some of this electrical and mechanical equipment, you can talk that out. You can do the same thing in a virtual classroom. However, that's done really through screen annotations, or guess what, through a whiteboard that with a really good camera angle that you can write on that whiteboard. It really depends on the instructor that their preferences and really what we can do. But what's great, and we're going to show you today, is an example of screen annotations. You can literally draw circles and lines and even text on a screen as the student as well as the instructor, and getting engaged in the skills that way. We're going to talk about that. In the classroom, the environment, right? Just think about the environment. The training room is usually the main environment of a training classroom session. Whereas you're clicking on a meeting link from somewhere, right? And the environment could change, right? You could be at home, you could be in your office at work, you could be anywhere, really, as long as you have an internet connection. Now let's really talk about the interactions you can have. You're having interactive discussions with the instructor in a well-built classroom where the instructor is asking questions and you're talking back and you're sharing your ideas and you're sharing your stories of, hey, well, this motor in my facility is 3-phase, whereas this one's only single-phase, and I've been having this issue, what can I do? Those are some of the best stories we hear time and again from the classroom. It makes the classroom very effective. However, guess what? Interactive discussions with the instructor are happening the very same way over the virtual format, especially when the students and the instructor both are sharing their video feeds where you can see their facial reactions and be able to interact in a more personal way by talking and gesturing and maybe even holding up the equipment that you have in your own facility and showing them the details behind it. Yeah. Again, both classroom and virtual, you're able to ask your specific workplace specific questions, whether it be about the motors you're using or the meters you're using or the equipment you're dealing with. And you can actually show your workplace equipment, whether it's the meter you're using, or you can literally, if you're on site at the classroom environment, you can bring that stuff in. Whereas if you're looking to build the skills on something at your workplace and you're logging into a virtual class from your workplace, you can bring that equipment and show it to the person over the camera connection, and they can really help you remotely, which is a really interesting concept. Now let's talk about really the hands-on learning, right? Yes, it is absolutely true that you are not able to get your physical hands on whatever the instructor has their hands. However, you can interact with it and learn from it, right? So here's the classroom example, right? Having hands-on equipment where you can, let's say, wire a circuit or work on some equipment in the classroom. In the virtual format, we're really seeing that the instructor can show a close-up, very detailed descriptions and tests and troubleshooting of components and devices and circuits for people live and in the moment, where everyone has that up close and personal view of what's happening, which isn't necessarily the case in the classroom where, you know, Greg, the people in the back room or the back row have maybe trouble seeing what's either being presented or what the instructor is doing with a meter. That issue is kind of eliminated in the virtual format. Not to say that virtual is better by any means. I just really want to let everyone know that some of the interactions you think can only be done in the classroom can definitely still be done in a virtual format in a very different way, but definitely a valuable skill building way all the same. So here's an example of a tabletop, and Greg's actually going to run us through another tabletop testing activity. This one right here is of a push button, and today we're going to talk about motor starters. And then students share equipment kits, right? So if students are sharing, obviously the days of sharing are long gone for a while anyway, with all of our concerns in the new era. But students can be delivered equipment kits in the virtual format, and that's actually what we do for our basic electrical classes. And students can work on their own equipment right off the floor, like we talked about. Students are working on lab activities, right, together. And what we're going to showcase in this one is students still can work on lab activities and interactive activities where they're testing voltage inside of a panel, but this panel is now virtual, and you can take remote control of the screen as a student and check the different parts of the panel. And here's one of those remote control simulated panels there. And finally, when it comes to getting that real troubleshooting skill, right? Troubleshooting skills is all about kind of a thought process, and building that skill can be done virtually, absolutely. Troubleshooting items with instructor guidance is what you do in the classroom to build those skills. And think of it this way, the instructor can be troubleshooting something and you can be providing that guidance and that input on a constant basis with them. What am I expecting to get from this reading? 0? Okay, why 0? And we're talking. right? Or the student can guide his hands, right? And say, all right, what should I do first? Oh, test from port 1 to port 7. Okay, what are we expecting to get and why? So there's all sorts of great ways, and it really comes down to the instructors, right, that are trained in virtual format teaching and reaching out to each individual student. So just to give you an idea of that skills, right, hard skills, practice-based skills can be gleaned in a virtual environment. It's just going to be in a different way, and that's what we're going to show you now. So what I'm going to go ahead and do is stop my screen share, and I'm going to hand it over to Greg. Now, what I suggest everyone do here in this part, if you see me and Greg side by side, you're seeing what we call a gallery view. And if you want to see Greg in the most detail possible, you can go ahead, probably in the upper right-hand side in the corner of your screen, you'll see you can switch the gallery view to a speaker view. So make sure you're in speaker view, and that'll make sure Greg and what he's about to go through with you is the biggest possible size for you to see the details. So without further ado, I'll go ahead and give it over to Greg. Greg?
Yeah, thanks, Ryan. And so one of the reasons you might want to switch your view is I'm going to be switching mine here. One of the most useful things we found is that we can, if you have a couple cameras or even three, it's pretty easy to switch between them because we want to show some real world stuff out there. So I'm going to switch a camera now over to what we might show guys when they're going over a meter to begin with. So this is all about building. You know, we're talking about building skills. Well, the key is to start out simple and basic. So we would at this point have already talked about different meter settings and safety. We probably in our basic class and troubleshooting too, we spent quite a bit of time on how to use a meter. Most of that's how not to use a meter. A lot of mistakes it's very easy to make a mistake with a meter. So let's just give you an example of something we might show them here. I think maybe Ryan and I should probably do a little role playing. Ryan, you want to play the student here? So
absolutely, I'd be happy to do this.
So I would say, well, Ryan, based on what we talked about before, right? We're on this scale right here. Now, what is that? What does that symbol mean?
That's the symbol for ohms, resistance.
Ohms, right, ohms. So since I'm not touching my two leads, right, we're not showing any resistance value there. What did we say OL stands for?
That's I used to think it was overload, but you taught me it's open line today.
Open line, right, open line. So yep, that's pretty common. So if I do put these leads together, do you think we're going to get high resistance or low resistance?
We're going to get low resistance.
Let's see if that's true. Yep, and we do, right. So let's use that to check something here. Let's say that we want to check a light bulb. And here from the snap kits that we sent you, and everybody that has a meter, please play along here. Everybody, what we usually do is send these kits out with these parts, but most people do have their own meters. Now we have a small meter that goes with these kits like that, but we really encourage them to use their own meters so that they can get used to their own settings. All meters are different. Most people do have one of their own available. So we say, what do we expect this to be? Well, it's going to be something higher than 0. We don't know what it is yet. But Ryan, what do we know if this is a good light bulb? What do we know we won't see?
We shouldn't see the OL because that would mean it's bad, right?
That's right. So let's see what we get here. We'll test this. And so, yep, you're right. So here we've led the student up to this point, and we build on it. For example, we've talked about series and parallel circuits at this point already. We've given them a concept, but now we want to show them the real life here. So we've given them the concept, we've talked about it, we've given them analogies such as the water analogy, voltage is pressure and flow is current. And now we've talked about this, now they're going to really see it. Ryan, what do you expect since we have two of them in series? What do you expect to see here across the
I believe, yeah, series circuits is when the resistance is adding up each time. So it's going to be double the resistance.
Let's see if that's true. Oops. Got it there for a second, didn't we?
Yeah.
Yeah, there we go. Yep.
Got it.
Give me one more shot at this. Yeah, there we go. That's pretty close to double.
Yeah, so it's 1.8, now it's 3 point something. That makes sense.
Yeah, it's better. Okay. Okay. So we have also talked about how adding resistance would make current go up or down. Which is it, Ryan?
Adding resistance should make the current go down.
Okay, so this is another one that we've given them the concept, and we've also shown any math that might go along with it, in this case, some Ohm's law. Now we want to show them that so that they really see it in real life. So they're snapping these things together. And as simple as these little things are here, the basic concepts that we're trying to get across, they're perfect for that. Plus, the assembly is really quick, and you don't have a lot of downtime in class. So here we have one light bulb there, right? And there we go. We had a loose connection. They're part of the troubleshooting class there. Ryan, we are on that. We are on the bottom scale here of this, right? So we see 0, 0.5, and 1. About how many amps is this one light?
This is just under half an amp.
Right, right. So if I take this off and add that other light there, right, doubling the resistance, do you expect that current to go up or down?
It should probably go down.
Okay, let's see if it does.
Now we're at a quarter.
Yeah.
That makes sense.
And so now they've heard about it, they've seen the concept, now they see it in real life. And why, Ryan? Why are they dimmer? We talked about that a little earlier as well.
Yeah, less current flowing means they just can't shine as bright, right?
Right. So yep, less current, less voltage too. Right. Okay. So we once we build those, right? We building blocks. Just start with the really simple stuff. And then we move on, work our way up. The things you saw there are pretty close to exactly what we'd be doing in our basic electrical class. So I want to show you one now where we would build our way up to this in the troubleshooting class. Our classes are not really set up that you have to take one before the other, but it's not a bad idea. Either way, this is one we would build our way up to, and I'm going to share a screen with you here that we would have for example, in our troubleshooting class. And this is another one that we can get the students involved with in a couple different ways. We found that in this virtual format, it's really important to use every resource you have, the hands-on things, the under the camera, a little bit of lecture, not too much lecture, as much discussion as you can possibly get, and then things like this. We can actually turn the mouse control over to the student. Let me give you an example of that right here, and Ryan will play the student again. Now remember, we've spent probably at this point right here, we probably will have spent about 7 hours getting up to this point. We start out with something very simple like relays, and then we adapt that knowledge, right? We make sure everybody understands every component of a relay and say, well, a starter here is just a big relay. And we make sure they can adapt those simple concepts to the more complicated ones, like this one here. So, Ryan, I'm going to circle a component up here, and then on the starter itself, and now I'm going to turn the mouse control over to you, and then I'd like you to show me where those components are in the schematic. Go ahead. You have control of the mouse there?
I do, yes.
Okay. All right. Just click and drag to make a practice circle there.
Okay.
Yeah, good. Yep, that's good. That's good. Now let me erase those for you real quick. Okay, now go ahead and circle the components.
Okay, this is that part of the motor right here.
Perfect. Yep. Now let's do one more. I'm going to point to a component on the schematic, and I'd like you then to show me, right? I took the mouse back. I'm going to point to this component here, and I'm going to leave that as an arrow control, but I'm going to pass over control. Now, click and drag and show me where that component is.
Okay, I'm going to drag it from here. Let's see. Over to here. That's where that is.
Perfect. Perfect. Okay. So in the classroom, everybody, we would be doing this for a while till we make sure that everybody knows where the component in the real life is and where it is on the schematic. And this is a critical skill that they need to have in the real world. They need to, if they don't have the skill already, this is something they need to develop. And this really helps them do it. So we spend a lot of time working up to this point. We spend quite a bit of time on this, but then we want to show them what that's like in the real world, right? So I'm going to stop that share, and our pictures will probably get big there for you. But now I'm going to switch the camera over again and put a real starter under here. Okay. So here's the same kind of starter we were looking at. We will have explained at this point that all starters are different, but this one's pretty typical. So we were just talking about overload. So let's look at this overload block, and let's see if we can't get student Ryan involved here again. And so Ryan, you had pointed to these two terminals on the picture of the starter in there. Mm-hmm. Those contacts were what, normally open or normally closed?
You had told us those were normally closed.
That's right. So to get them in the normal state, I'll push this reset button, make sure the overloads are in the normal state. And of course, we've explained what the overloads are for and how to hook them up and all that. So Ryan, what do you expect to see if I put my two leads here and here on these two terminals? What do you expect to see?
I should expect to see 0 ohms, or pretty close to it.
Let's check and see if that's right. And we do. We have something pretty close to 0. Yeah, that's right. Now, what if I push this reset, this trip button down here? It's a test trip. Our overloads had tripped because of too much current. Now, what should I see here?
Hopefully they should pop open, so the resistance would be OL, I think. Really high.
Let's see if that's true. And that's right. And if I hit this reset button, they should go back to their normal state. There they are. Right. So as you can see, you know, what we've done with everybody here is make sure that they get those basic concepts. And they're really pretty simple. Most of these are pretty simple concept. It's not, we get an awful lot of people that don't know anything at all about electrical work. And that's why they're there. And that's kind of how we approach it in the classroom. What we found is the guys that do have experience, they're not bored. They come in and they participate. They help the guy next to them. If it's a real classroom, since it's virtual, they can do the same thing. These guys can talk to each other in the virtual environment. It's worked out a lot better than I expected it would. We've had a lot of luck. Now, once they have those concepts, I'm going to share another screen with you here. And this is one that we also use in our troubleshooting class. We've worked our way up through motor starters. So for example, we would now troubleshoot a motor starter circuit. They've been given some instruction. We've walked through how this circuit works and that kind of thing. This is another place where we would say things like, okay, Ryan, could you point to a point there on the schematic and then show us where that is in the control panel. Sure. So let's do this again. Ryan, I'm going to point to a component here, right there. And now I'm going to turn this mouse control over to you. Just go ahead and click and drag. Go ahead.
There we go. And I am going to pick this spot right there, this guy. That's the C1.
Good, good. Now, let's do that one more time. I'll take control back, and let's look at a specific spot. This is where it can be just a little bit tricky because it's not numbered up there. So I'm going to draw a point here. Okay. And now
I actually realized I was wrong about C1. Darn it, sorry, I just learned something.
right. So, okay, where would that be over?
Okay, so now I'm over here on C1. So I'm going to look at this guy. Yeah.
Good, good. And then we would ask the student how did they do that, and we would pass it back and forth to as many people as we possibly can. Our classes have not been huge, so usually everybody gets a chance to do all this. And once they have a good understanding of the schematic, then we turn it over to them and say, okay, let's troubleshoot this thing. Ryan, I'm going to turn the mouse over to you, and you can just operate this and tell me if there's a problem or not. Okay,
okay. I'm going to try to turn the switch on to off and on again, and I'm not seeing much of anything happening, so I'm guessing there's probably not power.
Okay. Now at this point right here, we can check it. We have a meter there. So Ryan, over there on your meter, which one of those scales would you use on your meter? And
let me see, I'm going to slide over here. I'm thinking it's going to be, since we're dealing with a three-phase motor here, it's going to be the squiggly line, the AC voltage setting.
That's right. So you can just drag these leads over, show us where, show everybody where you would check to see if we even have power coming in, right? You see we have three-phase, but what is it that's not working? Is it the three-phase power, or is your control circuit not working?
Mm-hmm. Okay, so I would go from hot to neutral like you showed us. So I'm going to take the black one and I'm going to drag it over to this white guy for the neutral, and then take this red guy over to this hot. Should be here.
Okay, okay. So we have found that we do have power coming in, but maybe it's not getting to the coil, right? So if you were to just go through from beginning to the end of that circuit, that is from the hot to the coil, what would be the next place you would check?
Probably the other side of that terminal strip.
Okay, go ahead.
Make sure the terminal's good, so I'd pop it right to here.
Okay, now what's next?
Now I see we got that, so I'm going to move it over to the switch.
Okay, but could you do me a favor and take that red lead first up and show me the point on the schematic where you're going to be checking?
Let's see. Oh, there it is. Yep. So I see S1 right here is on the schematic. So it just came from the left-hand side. And I'm going to go to this spot. Yep.
Okay. So go ahead now and put it on that point in their control panel.
Okay. See? So that was right here in the panel here.
Perfect. Still there? No, didn't lose power yet. What's next?
The other side of the switch.
All right. Show me on the schematic first, please.
Okay. Oh, yeah. So it'll be this other side.
Perfect. Okay. And what did we just learn?
And I got 120 again.
Hey, Ryan, should I go to 0 or stay at 120 when you turn that switch off?
When I turn it off, it should go to 0.
Let's see if that works. Let's just try.
I'm going to go ahead and click it and turn it off. All right.
Yeah.
Doing good so far.
Okay. So go ahead and show me the next point. You don't have to show me on the schematic anymore. You can just trace it out.
Okay. So I'm going to grab this and go along this wire here and go down to terminal number 10.
Okay. All right.
Still got power, so all that stuff's good. And then the other side of the overload contact is 9. So I'm going to click 9 and test 9. Now I'm at 0.
Well, what did you just learn?
We lost our power across the overload contact. So my guess is something happened with the overloads.
That's right. Could you point to where you do have power and don't have power on the schematic, please?
Yeah, so across this OL, so from one side of this to the other side of that in the
And
schematic.
since it's normally closed, you should have it, right?
Right. Yeah, there should be power feeding.
Okay. So and we would have already explained that this has a reset button, which is not, it hasn't tripped. So you're right. So you found this wrong. And Ryan, what do you need to change?
So that means I can click that button you highlighted, and I'm gonna see. Yep. So I got control. Should be able to just hit that reset button. Is that right?
Well, in this case, go ahead and try to click it,
Okay.
and it didn't work, right? It didn't work.
Oh, I see.
So we have a bad what?
Oh, we could have a whole bad overload.
Right, right. So at this point, everybody, we continue this, and we could they can actually change the component out. They have to remember to lock it out and tag it out. If they don't, the program yells at them, and it's as real world as they can possibly get. We've had great luck with this particular simulator here, and I'm honestly not sure exactly how we would approach it without this simulator. It's we use it a lot in troubleshooting class. Okay, Brian, I'm going to take control back from you there.
Got it.
Yeah. Okay. And I'm going to share another screen with you right here. We'll go back to our PowerPoint. Yeah. And any discussion of electricity includes a discussion of safety. So that's traditionally in the classroom and virtually. It's hard to get people to get involved in this safety discussion. So here's another way we do it. And again, this is just one example here. So Ryan, you're the student again. You're looking at what's wrong with this picture. Is that correct?
Yes, I am.
Okay. So here we would have the whole class start listing things that they think is wrong with this, right? We'll probably just do a couple in the interest of time, but these kinds of things, not only are people participating, but they learn from each other at that point right there. And the class goes quickly, everybody learns something. Let's see here. I tell you what, in this case, instead of drawing on here, let's put text. Let's put text. So student Ryan here, I'll type for you. What do you think is this picture? Are there any mistakes being made?
Yeah, I definitely see the guy is testing without wearing gloves. So
no gloves. Good, good, good. Anything else bother you?
I see that meter is probably not the correct quality.
Yep. Yeah. Meter. When you're getting 300-400 volts, 480, 400 volts, well, yep, you probably ought to have a good meter. Right? And
yeah.
again,
and what I love about this, Greg, is that you're basically doing a whiteboard session without needing any sort of huge flip chart or easel behind you. You can use the screen share as your canvas and as your easel. I love that.
Yeah, that's right. And of course, the annotation too. It's like, well, what's wrong here? That kind of thing. Sure.
Definitely.
Here, what's wrong here? Any kind of interaction you can give them. Great. And speaking of that kind of thing and simulations as well, I'd like to give you one more on what you might see in our PLC class. We will typically use this in the programming class, but we also use this in our PLCs for non-programmers class in order to give them the big picture. We're not trying to make programmers out of them, but they do want to understand what's going on in that magic box there. Take some of the mystery away from it and give them the simple stuff. So I will share that with you as well. I just need to change screens here. Here we go. Okay, Ryan, you're the student again. So yes. What we're going to do is point. So first of all, though, we'll give them a little instruction. We'll say something like, okay, Ryan, if you're going to program this door to go up, you're going to need, since we have open and close buttons here, here's the physical button, and here are the addresses. We'll get to that in a second. input instructions, and you'll want to drag one of these down to here. You'll want to drag one of the output instructions also down to this line after it. And here are output addresses, and here are the input addresses here. I'm going to turn the mouse control over to you, and you go ahead, program this so that the garage door will open.
Okay, so no instruction is complete, as you said before, that it can input. So I'm going to grab an input. I'm going to drag it over to the programming ladder logic and plop it in. There we go. And then with each input, there should be an output. So I'm going to grab the output, drag it over right after the input. So now whatever the input does, the output will react to it. You told us we have to make an assigned spot for us. So for this guy here, I'm going to drag the open button. So I want to press the button as the input. So here it is. I'm going to drag it over, assign that to the input, and then let's see. How about I make the motor go up when I press the open button. So I'll drag this and go across here. There we go.
Good.
Now what?
Good. So you've written a program that says if we push this button, then turn on the output and start the motor. But we still need to download it. Do you see the little back arrow-like thing up there near the instructions?
Yeah, right here.
That's it. Go ahead and click that.
Okay.
Now you'll have to download that to the PLC. You see the download button? Go ahead and click it.
I'll do that.
Now that moves the program, copies the program from the laptop to the PLC.
Mm-hmm.
Left is to put this thing into run mode. You see the radio button run? Go ahead.
Oh yeah, right up at the top. Yeah.
Good. Now go push the button, Ryan.
Oh, we're live. Okay, so I'm gonna go here and just press the button. Oh, something happened just for a second. That's weird.
Yeah. So remember when we looked earlier at buttons and how they worked, what would we call that button right there?
Oh, that's a momentary push button. That's right.
Right. Momentary push button. So in order to get that to go all the way up, we could either put in some programming, or you could just hold it to go all the way up if you'd like. Do you want to try that?
Sure. I'll hold the button and then open the door all the way. So I'll just hold it down. Yep. Cool. So I'm just going to hold it all the way, and there, now it's open.
Oh, look what happened.
Oh, no.
Right. So at this point, we would, of course, talk about how to fix that, program in a limit switch. Everybody's pretty involved by this time. This is one of those activities that it might be one person controlling the mouse, but everybody is throwing out their ideas and trying things. It's also one of the great things about this simulation is that if you learn more by making mistakes in this one than you do by getting it right the first time. So people have ideas, they throw them out there, and that's how they learn, one little piece at a time. So Ryan, what I'm going to do is go back and share that last PowerPoint slide with you there. Right? Yeah. And we can finish up, right, and have some questions.
Yeah, definitely. So we just ran you all through just a small collection of some of these interactive activities that are possible in the classroom that are really in that technical building of skills kind of realm. We've been starting to get some really good questions from you all, and feel free. Now is our official Q&A session. So let's interact together between you and us. Again, there's a Q&A button on your toolbar. Feel free to type in any questions or curiosities you might have for us, and we're more than happy to answer your questions here as we wrap up the session over the next few minutes. So Greg, we've been getting some really good questions so far on the Q&A line. Let me pose one here. This one here there's a really good one. So basically, simulations are obtainable in both classroom and virtual environments. And you and I both definitely agree to that, where we can actually run through some of these simulations in a live classroom too, because we see how valuable some of these things can be. But the ability for a learner to test their skill development might be limited in the virtual format. For short modular courses of less than 20 hours, as I said, They're easier to create an opportunity for this kind of stuff, but providing, 72 plus hours of training, that becomes a lot harder for really complicated topics that really require a lot of hands-on skill. What advice do we have for kind of those longer term courses that are over a longer period of time and being able to successfully accomplish them in a virtual format? I would start on that one by saying, when it comes to testing your skills development, that's a tricky one, because can you test your skills development in the classroom? I'd say, it depends on which approach you take to skills development. There would need to be a specific kind of phase of where you get the instruction, you get the best how-to, and then you have to move on to a testing or verification phase. What we find in a lot of our customers we work with on our consulting service side of our business is we really have to set up a skills verification program for these people once they leave the classroom. So what I mean by that is people will take, let's say, this basics of electricity class and an electrical troubleshooting class, let's say in a virtual environment. Well, how do you know they really got the skills they need to get into an electrical panel safely and understand their job, be a qualified electrical worker, and move toward that safely? Even if they, let's say, took a written test, right, Greg? Like a 10 question quiz about electricity. Does that make someone a qualified person?
No, and that the fact that you mentioned qualified person, right? That's where all this comes from. Anybody that's ever even cracked open NFPA 70E or taken a look at OSHA or NFPA 70, what you'll see is it's pretty involved. What is a qualified person? One of the big things is you have to be observed doing that task, whatever that task is. You have to be observed doing it. So there are the skills, there's the understanding about it, and then there's the actual physical go out there and do it and watch somebody do it correctly. That's what it really takes. And we do some of that. The employers do it, but to actually be qualified, yeah, that's it. So as far as advice for people who are doing longer term courses, I would say don't wait till the end to do this. You can watch. It's harder to document it, but you can watch these skills develop over time. I mean, I see it in 2 days. I often wish I had them for a lot longer than that. But I would say teach it, watch them, teach, watch, test, and keep that up.
And for sure, I mean, I kind of call this out during many of our webinars, but really that 70-20-10 approach is what it's all about, right? The 10% of what you learn and retain is in that classroom. And then the 20% is through interaction with a mentor after the class is over. And that 70% that's remaining is just doing the job and practicing doing the job. So you're getting some of that practice in the classroom, but you have to continue getting that practice and verify and test that practice on the job. So I think I really wanted to mention to this question, answering this question is, skills verification is complicated and not everyone's going to be doing it the same way. There's on-the-job skills assessments, the OJT checklists that you can do, and they must be customized to your facility. But one kind of just tip I'll give you is any good skills verification program must be documented by you as the employer of those people, not necessarily by the trainers per se, unless you are the trainer as the employer. So definitely try to get a list of maybe competencies or skills you want people to learn and ways you plan on verifying them. There's oral exams like interviews, but there's also very specific task-based skills assessments that you can work on. And if you have any more questions about skills assessments, we got the knowledge on staff to help you with that. Just call that number you see here. Great question. Thank you.
It is a great question.
Yeah, it's a really deep question. And I can tell from last week and this week how deeply concerned and deeply curious people are about the virtual format, because it's a reality in today's age. And this is a great question. We're getting some excellent questions that I'm going to give you right now, Greg. And one is, how do you break the ice to get students involved at the beginning of one of these classes? They're sitting behind a computer screen, they're bored, they're just going to be sitting in their office chair for the next who knows how long. How do you get them engaged in breaking out of their shell?
Right. That's a good question too. And I see that several people ask the same thing there. Yeah, one of the things is getting to know each other instead of just starting off and talking for 8 hours. Have the people introduce themselves. It's very helpful. Sometimes we'll do that at the very beginning of the class. Sometimes it's helpful to do that maybe after the first break. I like to do it pretty early, and we find out what they do. We find out what their actual job is, what kind of voltages, hazards they might have, where they are, where they work, how long they've been there, and what we're really doing in the same time is we're figuring out what it is that they need out of the class, because every class we do is tailored to the people who are there, and that's of course a big part of their engagement. If not, if you're talking about things that don't relate to them, that it's pretty easy to tune that out. But if you find out what they need first, then it really helps to get them engaged. And on that same subject of keeping them engaged, one of the things I've been doing recently is right off the bat, as soon as early in the morning, tell them, look, this isn't a TV show. If you thought you were going to come and sit back in your easy chair and just watch this, it doesn't really work like that, right? You won't get a lot out of it. Let them know right off the bat that they're going to be participating, and they have at least a little warning when you call on them or ask them to explain something or talk about what kind of problems that they have at work. Get them talking. That's the big thing. Get them talking instead of just a speech. That's a big part. Yeah, great question.
Great questions, guys. Another really good question, kind of piggybacking on that, is, okay, well, now we've warmed them up, right? Well, we kind of get them out of their shell. How do we make sure they're getting the material, right? How do we make sure they're engaging with the material, understanding it, and achieving the course goals for those people in the classroom who might have a very diverse set of goals, especially if they're from different companies and different backgrounds, and different experience levels, right? Are there periodic quizzes and live assessments? How are we checking in with them? And yeah, how do we gauge performance?
Polls are great.
Yeah, polls are great for sure.
Immediate feedback. Polls before the class, before a subject. For example, when we talk about electrical safety, the PPE, for example, we would say, well, we launch a little poll that says, hey, what kind of work do you do? Are you exposed to energized parts? Have you had electrical safety training? How long has it been? What kind of PPE do you have? Do you have arc flash labels? Do you know what arc flash means? What does calorie mean? Things like that. You get a general idea of what they need and where they are now. And then you can do it again later. You could launch the same poll if you wanted to, if you really wanted it accurate, exactly how much they'd learned. I'll often ask for a comfort level. We'll go into relays and I'll say, hey, what's your comfort level on relays? Just a quick show of hands, 3, 2, right, 10, 0. 0 means you don't know what relay means, and 10 means you should be teaching this class. Scan and you get a general idea of what they know. You can do the same thing when you're done with relays, and hopefully the numbers have gone up. Right.
Yeah, absolutely.
But it's immediate.
One of our users, Greg, is curious, what type of camera are you using for that face-down tabletop presentation?
Yeah, right. It's a Logitech. Oh my gosh, the model number escapes me, but it's something like a 930E. That's
something like that, yeah. But one of those computer mounted that can be mounted on a computer, but in this case you got it attached to something, right? Like a little rig.
I'll be able to show everybody.
Oh yeah, there it is. So yeah, we've been really loving these desk-mounted stands that can really give you a face-down camera and move that thing around however you want to. I love it. So thanks so much for sharing, Greg. And when it comes to our training materials like that snap kit and the motor starter, are we creating these and building these ourselves, or are they purchased? The answer is a little bit of both. So we create our own custom training materials for our electrical troubleshooting and basics classes in the classroom. And we also purchased some things that are off the shelf that people would find, like that motor starter was not made by us. It's actually, you know, something you can buy on Grainger or something. But we take that and we create content specifically based around that. That is created in-house, you know, like our instructional materials and things. And speaking of those materials, someone asked, do you include breakdown worksheets with the training equipment so the students can reference it as they follow along? And both Greg and I know the answer to that is yes. So basically with those circuits you're building in the basics class, you're following along each step of the way and measuring voltages and ohms and current readings throughout those circuits along our workbook that we've created. And those are, there you go, there's one of the workbooks that are loaded with a bunch of activities, as well as a reference guide that they can use and take back with them. But those are sent and mailed to each attendee, I think a week or so ahead of the weather, or ahead of those classes. So great questions, guys. How long is a typical classroom? Right now, we keep it the same length as our typical open enrollment and or on-site classes from 8 to 4:30, our local time, or your local time, with an hour lunch and breaks throughout. We actually we're a little bit more lenient on breaks now in the virtual format. Sitting in front of a computer can be hard. So we're really trying to be flexible to the customer's needs there. But what I will say is that these classes, some are shorter, some are longer, especially for our ones delivered privately to, you know, individual customers in their departments. They can be a 2-hour class, it can be a 1-hour class, it can be a 4-hour class, is pretty popular, or just a 1-day 8-hour class split over the course of 4 days for smaller groups. It really is, it's all possible in terms of time length. But our typical open enrollment public courses that anyone can register to are about 8 hours, 2 8-hour days per course. So I think we got a lot of these answered. This is a good one on the development side I think I can speak to. And both Greg and I have worked on this together over the years. Is how long does it take to develop a class specific to our needs? And what I take that to mean is it's specific to an individual's company's needs, customized for that customer's needs. And can our instructors teach? Can our instructors teach those courses? Can a company's own instructors teach those courses? And the answer is absolutely. So it's called the custom course. It really is a custom project at that point, custom course development, and we do it all the time, especially for our you know, customers who have specific needs. It becomes a more consultative approach at that point, where we gotta get on site before we develop this class, understand all the equipment that we're using, makes, models, manufacturers, and incorporate that into the learning we're developing for that classroom. Absolutely possible. And again, in terms of class length and, you know, the scope of the class, it's all possible given our expert instructors that are on the projects, or expert instructional designers who can design really great interactive material. We're doing one for a wood creation company now that has really great interactive components to each module that people can click through online and then practice it in the field. It's kind of a whole program that's being considered here. Let's see.
Such good questions. If we just stay another 6 hours, we can answer them.
Exactly. And kind of like we were mentioning throughout this, we only scratched the surface of some of the technical discussions we're able to have. We just wanted to show you as much as possible in a short period of time. In that simulator, Greg, here's a good one. I can only pick a few of these questions, unfortunately, but does Greg have control of what faults he can put in the system? Are there certain ones you can still pick out, let's say, in that simulator?
Yeah, right. The answer to that is no, we don't create our own faults in there, but the software comes with about everything you can imagine. I mean, there are so many of them to pick through. My favorites is I always pick one that has a bad neutral, for example, because that's going to come up in my lecture. That's going to come up when we start troubleshooting. It comes up in real life. So I can pick the ones that I want, and I haven't had any trouble finding something that I want out of the huge list of pre-made faults that are in there. Yeah.
Mm-hmm. Definitely. Let's see. What do we got? Let's see. So this software is called Simutech, and you can definitely look into it in more detail. It's definitely out there for people to gain license to. Let's see, how often do you find students need breaks in an in-person class? It's definitely, in an in-person class, it's about every hour, 15, hour and a half time frame, or between 45 minutes to an hour and a half, we take a break. So that's about 2 breaks every morning and 2 10-minute breaks every afternoon to make sure people can take the information they're getting, digest it, decompress from. There's a lot of information, technical, highly technical information in these classes that are happening in a short period of time, relatively. So learning styles dictate those breaks. Let's see.
I saw a couple, Ryan, about cost. I can tell you cost for those simulators. And, I still, the Simutech is subscription based. And I don't have a number on that, but the PLC simulator I showed you, you can get that for $35. It's not a subscription. That's yours forever.
Yeah, that PLC simulator, it's great. It's from the Learning Pit, and you can find out more about it for sure.
TheLearningPit.com. If you guys, anybody's interested in the PLC, TheLearningPit.com. We pay for it just like you would. We're in with them or any kind of anything like that. It's just this probably the single best bang for the buck you can get with that program. It's simple but just great. Yeah, $35. Simutech's going to be more than that.
It's The Learning Pit, like a pit you fall into. TheLearningPit.com is the name of that website. And is there virtual training available for other kind of technical trades? I know we focused on electrical here because you're an electrical instructor with us, but also maintenance, plumbing, other skilled crafts. Absolutely, our TPC is kind of the leader in all those maintenance topics, from mechanical, HVAC, and electrical. Do you always have a moderator to assist you when instructing? And the answer is not always, but at the beginning of each class, Greg knows I'm on his support team. So basically, when Greg's teaching a class, I'm there at the beginning of the class, about half hour to 45 minutes before it starts, just to help him set up his audio, his video, his screen share. And we have a whole team, an operations team, that is logging in and helping each instructor set up audio, video, screen share, and the whole experience, playing videos in a virtual classroom, how to see the equipment in the virtual classroom, troubleshooting your internet or your computer. There's all sorts of fun stuff that can happen on the back end that, yes, we absolutely have someone on hand to help them, but they're not going to be there. The instructor acts as his or her own moderator during the class, plain and simple. So it really is interesting, and that's something we learn in the virtual format over the years is an instructor not only has to be the expert on electricity, they also have to be the guide for people on how to click the buttons on their screen and interact with the material, and how to unmute and mute their microphone, right, Greg? And you have to be that warm-up person. You have to be kind of a computer expert on top of being a technical expert. So not all instructors, have that skill, but it requires some, training on our end to make sure we can do proper virtual training as well. So I think without further ado, I think that's all we can get to, unfortunately. We want to respect your guys' time to keep this to an exactly hour presentation. So we really thank you for being here and learning. Hopefully you got some really good juices flowing about the topic of virtual training and how to conduct it either for yourself or how to engage with it in the future. Again, if you have any more questions about virtual training, what it's about, how I can maybe, how you yourself can offer training, or how TPC would do it. Feel free to get in touch with us, sales@tpctraining.com. That's basically our whole consultant staff that can help you with any questions, as well as our phone number. You can call us and you can talk to me or to Greg or to anyone you want about these topics. So thank you for being here. Look out for the recording within a couple days of the webinar on our website, and have a wonderful day.